Welcome back. In this video, we'll recap how to evaluate arcsine. In the example 1.2.3, I use our knowledge of trig functions to evaluate it. I'm going to give you a more straightforward method that doesn't rely on your understanding of trig, just to make sure that if your trig is weak, you can still do this. And then we'll do more examples. All right, so here's the method to evaluate arc sine of x. Step 1. Find theta, so that sine of theta, well, we want sine of theta to be equal to x, but what's going to be easier is to find sine of theta is equal to absolute value of x. It's going to be easier because we have this stable that we saw in the review of trig for the first quadrant. And so for positive sine value. Now, if x is positive, then you found your value. That's the right angle because sine of theta is x. If x is negative, then it's not quite the right angle. So you found this angle, you want that one. So instead of theta, you're going to do minus theta so that you have a negative y value, and so a negative sign. All right. Let's do example 1.2.4. I want to evaluate the following expressions. It's going to give us a bit of practice with this, but also the goal of this example is to see whether arcsine and sine cancel. Why or why not? All right, so arcsine and sine are inverses, but they're not full inverses. We had to restrict the domain of sine, and that's going to come into play. All right, let's start here. Let's evaluate sine first. Sine of pi on 3 is here. So if I have theta is pi on 3, sine of theta is root 3 on 2. And now I'm going to try to find an angle whose sine is root 3 on 2. Root 3 on 2 is in the sine row. I'm going to look at the angle above. So this is pi on 3 back. All right, so in this case, yes, they cancel because I went from pi on 3 to pi on 3. Before we answer the final question, why or why not, I want to look at the second example. All right, in that case, 5 pi is not in our table. It would be right here. So we don't have 5 pi, so we have to go back to our trig circle. And this is pi, 2 pi, 3 pi, 4 pi, 5 pi. Remember, pi is a half turn. It's 180 degrees. So this is 5 pi. So I'm at this point. Sine is the y value. So is the y value at 5 pi. And from the picture, the y value is 0. And so I am looking to evaluate arc sine of 0. So arc sine of 0 means I'm looking for 0 in the sine column. And I want to return the angle. And so sine of 0 is 0. All right, so in this case, oh, sorry, I wrote theta. I meant 0. So right here, it's a 0. So in this case, when I apply arcsine and sine to 5 theta, I don't get 5 theta back, 5 pi, sorry. I don't get 5 pi back, I get 0. So no, they do not cancel. All right, now I want to answer why or why not. So if I'm just looking for an angle whose sine is equal to this value, x, then 5 pi would be a valid answer. However, I have a second condition. Let me go back here. So 5 pi would have worked here, but I have this second condition that I need to find an angle between minus pi on 2 and pi on 2. So even though 5 pi would work for the first condition, I'm not allowed to use it because it's not in my chosen interval. And so here it doesn't cancel because 5 pi is not in our chosen interval for arc sine, and so it would never be a value that you could get out of it. All right, and here they cancel since pi on 3 is in my chosen interval. So this is the interval on which sine and arcsine cancel. So if you start with something in it, then you would just cancel the sine and the arcsine and get pi on 3 out of it. If you're not in the right interval, then instead of giving this point, you would have to go back to the point with the same y values, same sine value, but in the right interval. And so that's why we end up with 0 instead of 5 pi. All right, so let's write this down, and then we will move on to arctan. All right, so for arcsine, we only consider angles between minus pi on 2 and pi on 2. So in my trig circle, I'm only allowed to go from minus pi on 2 to pi on 2. So only the first and the fourth quadrant. Now the functions arcsine and sine cancel on the appropriate intervals. So this would cancel as long as theta is a possible value. So this would give you theta if theta is in our interval, minus pi on 2 and pi on 2. Arcsine and sine would give you x. That's going to be true for the whole domain of arcsine, and that's minus 1 to 1. All right, a third note. You may see the notation sine to the minus 1 for arcsine. So the inverse function, we use minus 1, so they use minus 1 here. I'll try to avoid it because I find it often is confused with 1 over sine, because we put exponents in the same place, but 1 over sine is cosecant, and it's a different function from arcsine. All right, so I'll use arcsine, but be aware if you see somewhere else sine to the negative 1, they actually mean arcsine, not cosecant.